Thanks, everyone. Hello. How's everyone doing? Great. Awesome. That's good to hear. We are going to move pretty quick today. So I'm going to warn you, we're going to move very quickly. We've got a lot to cover in a short period of time. So I'm not going to explain what services do, what they mean, etc. That can be homework if you don't know it, or you can just nod wisely along. We're going to talk about operational optimization, infrastructure optimization, and architectural optimization. And my goal here for you today is to leave the room with at least one good idea that you can take back to work and apply. Now I'm going to show you lots of pricing, and I've gone through the deck, and it's all for the Singapore region. Each region has different pricing, so I've customised this for us so that it's familiar to you. Now, you're here because you want me to show you the money. There's a lot of maths involved, and a lot of slides flicking past. So I've tried to make it easy for you to understand the savings that you can get. And I've used these little Randall things that you're going to see pop up when I click the next button. There we go. And this will show you the percentage of savings based on what we're doing. And you'll see there's some pretty significant numbers up there. I haven't given you little savings, it's all big savings today. So let's talk about architecture. Now, I believe there's a new domain for architecture that we need to think about. In the past, we've thought about availability, performance, security, and of course, functionality of what we're doing. But how many people think about economy? So you can think about how economical your architecture is through its life cycle. You can see how you can attain the same or better capability for lower cost than you're currently doing it. You can make changes during the life cycle of the system. This is not a world where we make a big capital expense up front and we're stuck with the hardware, the infrastructure, or even the software choices that we made years before. We can make radical changes, and sometimes this can be driven by changing business models or economics. Other times it can simply be driven by the fact that new, different, and more cost-effective technologies become available to us. You also need to understand your transaction cost and your operational cost. And it was interesting when I was thinking about putting this all together, I actually went down one direction, which was about your per transaction cost. How many of you in this room know, for key systems that you care deeply about, what your per query cost is? Or per user cost? Or cost per hour? Who here tracks it in real time? Who here shows it somewhere? Not many hands going up. Usually when I do this talk, maybe 2 or 3 hands go up. And then everyone sort of goes, yeah, we probably should be thinking about this stuff. So you can. So a few actionable steps. Firstly, the beginner level is simply figure it out by hand. You can use the AWS Cost Explorer and you can figure out what your average cost is divided by your number of transactions. If you want to be super advanced, you can monitor in real time, instrument your application and put it up on the wall somewhere and have your development teams tasked with make that number go down. There are many organizations that have that as a key metric, because it's cheaper to run things if you build them the right way. So let's talk about some of these optimizations that we can do. So the first is operational optimization. Now, I've given this talk all across the world, so I've sort of put together an average of pricing of what we pay for a typical database, a typical systems administrator to do their work. And it's different depending on the region. And these are median prices. Yeah, everyone's looked at the Singapore price, haven't you? Yeah. I noticed that too, believe it. This is not my data, there's my reference. But it's okay, because none of us hire median people, do we? We always hire the top, the very top. It's the same with DBAs. Interesting, similar spread of pricing for everyone's interested on their hourly rate now, aren't they? So let's think about what it costs for a database administrator to do their job for an hour. Let's think about patching or updating a database. Just a minor DB version. What do you got to do? Got to back up the primary, back up the secondary, back up the operating system. I've got to gather together all the binary files. Not a trivial job. We typically run it as a test, do a change record, have a backup plan, etc., etc. If you're doing that in less than 8 hours, you're doing pretty well, aren't you? Or you could use the relational database service, and you could simply verify when you want to make the change and have the system do it for you, and you're simply verifying the success. An hour or less. Because the system allows you to select when you're doing the update, what window you want it to take place, and moreover, it allows you to record and understand what the change was and be able to provide evidence as part of the change record for your auditors as well. Suddenly your DBAs can do important things like tuning the database, fixing slow queries, working on that next project, etc. It also means that every single time you upgrade your database, it costs you much less. So for example, in Singapore, it costs you $133 less to do that change each and every time you do a database update. It's funny when you think about it in that context, isn't it? What about at the infrastructure layer? What can we do there? So one example is to take advantage of the Amazon S3 storage tiering capability. And this is very easy because we can make changes without having to change code or systems because the interface to S3 remains the same even when we're using this. So let's work an example. Let's take our application storing 100 terabytes of photos. Each photo is about 10 meg, and that costs us nearly $3,000 per month to store that information in a highly durable, resilient form. Now, if we set up a policy on this bucket to say, you know what, after 30 days, most people don't access their photos, or they do it very rarely. In fact, only 20% is accessed less than twice a month. We can move 80% of that. So we simply set a policy, the system takes care of it for us. We immediately, out of the box, save 17% on our storage cost without doing any work except for setting up one policy. When was the last time you saved 17% on your storage cost without doing much work? Not often. What about compute? If you're using Amazon EC2, you should be revisiting your selection of instance size and type at least every 6 months, if not more frequently. Why? Because we often change the families that are available to new and more powerful, cost-effective instance types. And secondly, your workload will change over time. And you can change your instance types trivially and get the most benefit. You can also use Trusted Advisor for some hints. Let me work an example for you. Let's take M4 4x large running Windows compared with an M4 extra large. You can see $1.73 per hour, 43 cents per hour. That's the differential. So if I'm running my application and I can see that in a general sense it pretty much pegs out at 15% of the CPU, I've probably got too big a size of instance. So if I shift that over to the smaller size, the M4X large, it's just an experiment, I can change it back if I need to. I can see here that I've got plenty of headroom. In fact, there we go. In fact, if I bump it up, you can see that I've still got plenty of space to go if I want to. I'm running at 60% utilization. Very comfortable with that. Nice and safe. Well, that represents a 75% saving. Now, at this point, I've got to give you a warning. If you go to your chief financial officer and say, I've saved you 75% on your compute cost, they will probably hug you. And most people in this room don't like to be hugged in that way, but this is the hug zone, so just be aware, because it's a pretty big saving. Now, you can use a Trusted Advisor, which is part of AWS support and is free for all users to see what things can be optimized, what things aren't being used very often, are there systems that aren't being accessed that should be turned off, etc. Lots and lots of options. What else can you do? You can use spot instances. Spot instances are fantastic. This is where you bid on capacity in EC2, and as long as your bid price is higher than the market rate, excuse me, you get access to the infrastructure that you need. Now, this is often used for experimental workloads, development workloads, etc., but can also be used in combination with on-demand and reserved instances. Let me show you how. So first bit of code on the board today. So this is part of a CloudFormation template that builds an AutoScaling group. An AutoScaling group allows us to grow and shrink instances on demand based on workload or other metrics. Now, if we want to introduce a spot instance-based AutoScaling group, we have to do a lot of code changes. Well, actually, we just add one line. And that one line says how much, look, the red's too high, it should be on the spot price. It says how much do we want to spend on our spot bid. That's all. So what does this look pictorially? Well, this looks like this. Basically what we have is our load balancer, but now it's sending workload to an on-demand pool of instances and also a spot instance pool. Now you may say, what happens if my bid price gets overtaken and I don't have any spot instances? You can automatically have your AutoScaling group build out your on-demand pool for you, so you can grow that way. Now, what does this mean? Well, it means we have a lot more options to play with. So we want to look at what price history is. You know, Simon, you tell me that I'm saving money on spot. How much can I save? Well, luckily we have this handy-dandy visibility in the system that can show us what the historical price of spot instances are. So this is the M3 medium in the Singapore region. There is a line there. It's very low, isn't it? Doesn't seem to move very much. So that tells us that the price is low and generally stable. And when compared to the on-demand price, you can see there the on-demand price is about just over 9 cents, and the spot price is bouncing around just over the 1 cent mark. Sounds cheaper to me. So what can we do with that? Well, let's use a model where we've got 12 instances that we're trying to build for our cluster. In the on-demand model, remember we talked about the hourly cost? $1.17 per hour to run those 12 servers. However, if I say I'm going to have 2 servers running at my core on-demand and the rest is spot, suddenly I'm down to 32 cents an hour. 72% saving, a couple of lines of code. Back in the hug zone again, aren't we? Scary zone to be in, but that's where we spend our time. What else can we do? Think about your developers. All your developers work really hard, don't they? 10 hours a day, Monday to Friday, sometimes the weekends, but at some point they have to sleep. So you need to turn some stuff off. In fact, DevTest is a place where just by turning things off, you can get 70% savings on your costs. That's why a lot of organizations move Dev and Test first, because it gives them the opportunity to save money up front. Now, there are many ways you can do this. You can use tagging, you can use Lambda to control it, you can start up based on time, based on request. I don't really mind what you use, but please use something. There are many tools out there that you can use. This is what I call my incomplete list of tools that can help you. So a few links there. There are many different tools that you can use to make this happen. Just make sure you turn things off overnight and on weekends. So let's move on. Told you we cover a lot. Caching. Caching is an unloved and unattended area of IT at the moment. Now, I'm not going to be able to explain to you all the wonderful benefits and techniques that you can use for caching, but there is this amazing white paper that tells you all about it that I highly recommend. But in this particular example, if we have a heavy read workload that's doing 30,000 reads per second and we want to shift it from using RDS into Elasticache, so it's an in-memory database, we've saved ourselves 96% of our cost. That's getting to ridiculous levels now, isn't it? Now, yes, a bit of work required. For 96% saving, is that worth it? Probably is. At least we're thinking about it now. So what else can we do? What about architectural optimization? Everyone in this room is super lucky because you have way more levers to pull than you ever had before in the world of IT. Because everything is available at the end of an API, everything is on demand, everything is pay as you go, pay for what you use with full elasticity. That's a pretty good place to be, so we need to behave accordingly. What this means is that we can change code along the way, even small changes, and get huge benefits. We can make informed architectural trade-offs between different design patterns and immediately see what it means to our bottom line in terms of cost of running the system and make informed choices, or have our business stakeholders make informed choices. So let me give you some examples. What's your web tier doing? That set of web servers that you patch, maintain, look after, worry about, protect, etc. In many cases, it's not doing that much, and in many cases, it can be easily replaced by Amazon S3 static web pages. Now, the phrase static web pages doesn't do it any justice because you can run JavaScript on these pages, and you can use cores as well, which means you have a fully featured front end that can serve millions of requests. No servers, no patching, no scaling to worry about. That's pretty cool. What does it cost? Well, let me work an example. The typical size of an object these days, or a page per these days, is about 2 meg. And the average number of objects is 150 objects per page. So let's assume it's 100,000 page views per day. You can see 450 million gets per month, something like nearly 6 terabytes of data transferred over the month. You're talking less than $900. It's pretty cheap. Plus, you're not doing web server patching, your attack surface is smaller, you're not doing security rollouts, etc., and your content update is really easy. Hours per month you're saving. What else can we do? Queues. I'm a big fan of queues. Queues are really handy for decoupling, for resilience, for microservices, all that good stuff. But they can also be used to manage cost, which is a little bit different. Let's work an example together. Here's an application I've got which has a mobile client that dumps images to an Amazon S3 bucket, and then that bucket will have the image processed for some purpose. Now, I have a freemium model, free or paid service. For my free service, I want to optimize for cost because I don't want to pay too much for free customers. For my paid service, I want to give them a high level of service. So we know that a single instance can process 1,000 images in an hour. I also know that for my paid customers, we don't want them to wait more than 10 minutes for their result. So my free workload will go into an AutoScaling group that is built based on the number of outstanding messages to process, so we run the full hour, so it waits for there to be 1,000 messages. My paid queue will not let me be more than 10 minutes, I should say, out of sync with updating my customers as well. So 2 different queues running in 2 different models. Let's do the maths. Let's say it's 50-50, 1,000 transactions, 50-50, so 1,000 going through each type of queue. We can see that the free queue costs $0.000125 per transaction. My paid queue costs $0.00075, so significantly more expensive, but I'm happy to pay that, aren't I? Because I want to have that customer engagement. But how can I make this cheaper? Well, I could simplify it. I could apply Lambda, and what I could do is have a Lambda function spin up, do the processing, turn off anytime I want. And this can be triggered by an S3 event. Now, what this means using this model is I can actually save 59% on my per transaction cost. What does that do to my business model, my operational cost? It's pretty exciting. What did I have to do to make that event happen? All I had to do was activate a trigger on my S3 bucket. Now you may say, but that transaction cost is still higher than your free tier was, or can't you use spot instances to make the free tier cheaper? And the answer is yes, you can. So you can combine both models. You can have a queue for the free tier going into a spot set of instances, and you can have Lambda being my paid tier, and I can eliminate my 10-minute SLA because I've got near real-time SLA now as well, haven't I? So I've improved everything in my architecture. What else? Databases. You may say, Simon, you've been playing with the easy stuff, stateless services, all the fun stuff, but what about databases, which are a royal pain to manage? Well, what you need to think about is that not everything is relational and not everything is NoSQL. We can choose which we apply to what. Often you'll find caching can make things more efficient. We spoke about that briefly. You'll also find that using an analytical database for transactions is not good, and vice versa, so you need to think about that. More often than not, there'll be not an overloaded database, but a selection of tables within a database that are overloaded, and that's why you make the database itself quite big. How can we solve this? As an example, we can look for hotspots, and we can move those hotspots to where they belong, maybe, for example, something like DynamoDB. Here's an example of a hotspot, 10,000 IOs per second, 80% read, 20% write, 3 terabytes of capacity in that table. It's a big honking table that's pretty uncomfortable in a relational world. If we can convert that to a NoSQL world using DynamoDB, we've saved ourselves 38% just on the cost of operations, let alone the management cost, the overhead, and the scaling issues that go away as well. So what am I trying to say here? I'm trying to say that architectures can evolve and should evolve over time. Let me give you a little worked example. So I thought to demonstrate this, what could I build that was small but useful? And I chose what I called a restroom finder. In Australia, we have a whole lot of open data sets, as I'm sure you have here. And one of those data sets is the public toilet map, which gives us a whole lot of locations of public toilets around Australia, which is really handy. So I built a microservice. I just grabbed some Python and Bottle and MySQL, and I wrote some really ugly code to basically create myself an API that I could call with a postcode, and it would return me a list of toilets. Pretty straightforward. And I went to deploy this, and I used a pretty common model. I said, I'm going to deploy using Amazon Elastic Beanstalk. It's going to build me my ELB, my AutoScaling Group, my SQL database. It's going to be all replicated and secure. It's going to be sensational, which it is. It's fantastic. Except I don't have management of my API layer. I don't have security management. Feels pretty heavy on the storage layer for what I'm doing. And I still need to do rolling patches and that sort of stuff, even though that makes it pretty easy. So I thought, well, what can we do? So I passed it on to one of my colleagues in my office and said, hey, can you containerize this for me? He said, sure thing. And he went ahead and containerized it, which is great because he can say Docker all the time. We all like to say Docker a lot, don't we? That makes us happy to do that. So that's great. It means we can spin it up and spin it down quicker. It used ECS to run the containers, which is great. But I hadn't fixed the problem of having to manage the API. I hadn't fixed the storage layer. Still got to patch the containers, so I'm not much better. So the next thing is to lambdaize it. So I've got rid of that server layer altogether. So now my scaling is very well matched to my load, which is great. I'm using API gateway, so I don't have to manage the API, security, DDoS protection, throttling, done. I don't have any service to patch anymore, but I've still got this heavyweight storage layer, don't I? So what's my next evolution? DynamoDB. I NoSQLize it. So suddenly I've got all this highly tuned, really effective platform, and I get to say serverless a lot, which is even cooler than saying Docker a lot, so that's the next level. But what is the downside? Well, it's a less familiar deployment and operational model. And that's where you need to look at uplifting your staff skills and your capabilities to be able to deploy in this way, because it gives you the option to do so many new things. Now, the code itself to do this is not complicated. Remember the code I showed you at the start? This is the code at the end. All I've done is replaced a call to a relational database with a call to a NoSQL database. All I've done is replaced some SQL with an API call to DynamoDB. Everything else is the same, but this is a far better solution. So I've told you about the good stuff. What about some anti-patterns? What about things to concern yourself with? Well, let me give you an example of two that I see very often that I want to raise to you. So the first one is product owners will often push for something to be cheap. Lowest price, cheap, 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 and then it goes down because it's not built to be highly available, and then they go, but it has to be up all the time. So you need to try and educate people to say first availability, then cost. You need to prioritize those two things appropriately. Now, one option that you have if you're running in a region that has 3 availability zones, so many of you will run workloads in the US or Australia, etc., which do have 3 availability zones in a lot of those regions, is you can get a much lower cost in terms of running active-active across multiple availability zones. In this example, we have an application where we need to run 12 instances all the time, even if a whole AZ comes offline. If we can deploy across the 3 AZs, we can still tolerate the loss of availability zone, but we need less running instances to achieve that high availability. So we can do it for 25% less. The other anti-pattern that I want to share with you is using a database as a blob store, a relational database as a binary large object store, i.e. storing big files in relational databases. It is a really bad thing. Now, I know no one in this room ever does it. We only see people who do it and tut-tut at them. If you ever see this, just understand it's bad because it's hard to get good performance, it's very expensive, it's almost impossible to back up, and it's a nightmare to manage. Let me show you why. Here's our sample table. Creating a table that stores user images. The user images has a user ID, the image GUID, and the blob itself, because that's the lazy developer thing to do. Just chuck the picture in with the table. What could possibly go wrong? Well, if I've got each image being 2 meg, and I've got 3 million of these images, I've now got a nearly 6 terabyte database that I've got to manage. Now I can do that. I can have my RDS MySQL, I can have it replicated, standard storage. It's still going to cost me about $3,200 odd per month to run. Or I could build it the way you're supposed to build it, which is the same table with the same key and the same GUID, but instead my URL, my image is stored in S3 and I have a table pointing to the URL of that image, and that's where I get it from and that's where I store it. So now my database has gone down to less than 6 gigabytes instead of 6 terabytes, and it's not hard to manage a database of 6 gigabytes. S3 storage is efficiently serving all the workload that we could possibly want, and our price is 50% less overall. So you're winning on all fronts. So this is an opportunity for you to explore a new domain for architecture. I want you to open your mind to the idea of economy in what you build. The ability to get the same or better outcome for a lower cost. The ability to change how the system is built over its lifetime, whether you can build it or change the code yourself or simply the underlying infrastructure components. That you can make really significant changes. This is not about saving 5% or 10%. This is 50%, 80%, 90%. It's really significant changes that will get the attention of people who really don't care about IT, but care about the bills that they pay for the IT. And there are always changes in the services that can be consumed. Something that didn't exist today can exist tomorrow that can allow you to operate cheaper, easier, and better. A really simple example is this month we just launched per second billing for EC2. Again, changes how you might choose to build your systems. And remember to keep in mind your transactional cost and your operational cost, and at least have a feel for what it costs to operate these systems, because that will help you make those informed decisions. We covered a lot, but I got you out in time. I hope you each got one thing out of this presentation, and thank you so much for being here today.